What is up, everybody? Welcome to the Data on Kubernetes Communities live stream number 155. That is right, we're getting up there. We're racking them up after 2.5 years as a community. We've got plenty of content for you to check out at all times. And speaking of which, if you have not seen our latest and greatest research report from 2022, definitely take a look at the link that I'll drop here in the chat, where you can check out all the interesting things that are happening there, respected to new workloads that are making their way in the Data on Kubernetes ecosystem. And we're talking about machine learning, and we're talking about AI. And today's very special use case, we're looking at edge computing, looking at K3s, looking at ARM. But more importantly, we're here with a wonderful person who is no stranger to our community. His name is Sergio Méndez. He's very, very active in the cloud native ecosystem. KCD Guatemala organizer, very, very active in many different projects. I don't know how he has the time. And on top of it, he wrote a book. But Sergio, very nice to have you with us today. How are you doing?
Thank you. Well, all good. Just like a little bit nervous about this presentation. Now, I think that it's really nice to be here and share with the community and share what I know. So, yeah.
Good. For folks that don't know Sergio, I'll definitely, well, you should know him already, but I'll put his links. He's very active on Twitter and LinkedIn, so you can be in touch with him as well. That being said, Sergio, how did this idea for writing a book, when did that start?
Well, I think that Packt publisher contacted me the last year on March, more or less. So they proposed me to write about edge computing. So we started to discuss about the topic and define the scope of the book and everything. And I asked them about why me. and they say that, well, we know that you have a really nice background, you are a professor and everything. So we think that you can write a book. So that's the way that Packt editorial found me on LinkedIn. It was like the way that they found me online, not in person, all online. So that's the way that I started to write a book. So that's the story.
Very, very good. Well, that's good. I mean, I think what the main point here is be proactive, be involved, and people will find you. So I think that's one of the lessons here. That being said, you have a presentation that you'd like to share, and we're also going to see, I believe, a Raspberry Pi cluster.
Yeah. Let me share that part. Where is it?
Okay.
Let me see. Hold on.
No worries. Take your time.
Just let me. Okay. I think that here is it. Let me share my screen.
All right. Ooh, that looks nice.
Yeah. Let's say that here's my finger. Let's prove that it's real. Here's my finger too.
This is absolutely right. This is live TV, folks. This is the magic of doing things live.
Yeah. So yeah, right now is my Raspberry Pi running. Well, I am just using the last one in the last row in this side. So, well, the other ones, I used to use them for the experiment a little bit. So the one that I'm going to use is the last one. So let's say that my live demonstration is going to use that Raspberry Pi.
Okay.
So I think that I can start to talk about my topic, I think.
Yeah, let's do it.
Where is it? Oh, here is it. Okay.
It's okay.
So, well, the topic is like related about my research in the book about ARM devices, running Kubernetes at the edge. So in this case, I am going to use K3s, that is a lightweight Kubernetes. But this topic is more focused on data. So I picked this topic about how you can use the databases at the edge, how you can deploy it using K3s, a lightweight Kubernetes. Well, a little bit about me. Well, I am a professor. I am from Guatemala. As Bart mentioned, I have the Cloud Native Guatemala group here. I am also a Linkerd Ambassador. Right now, I am an author of a book. That's really nice. I am also do some DevOps at Yalo. Yalo is a company that works on WhatsApp chatbots and that kind of things. So we use a lot of Kubernetes there. So let me introduce you to the topic, edge computing. Well, what is edge computing? Well, here is a lot of concepts there. Then maybe we can say that, let's say that you are close to the source of the data. So instead of processing the information in the cloud, you are going to process the information close to the source of the data. Let's say, for example, as you saw the Raspberry Pi, I am going to process the information in the Raspberry Pi. Once the result is completed, I am going to move that data and move it to the cloud. In this scenario or in this demonstration, I am going just to process a simple information, just write into a database and show the information. So basically, that's the edge computing. That's what I mean. Process the data near to the source of the data. So it's in complement, I think, of IoT. IoT is more like using sensors, capture the data, but move that data to the cloud. In this case, edge refers that you are going to process the data near to the source. Why? Because you can reduce latency and you can improve the user experience for the applications. That's why edge computing is about. So edge computing has a small architecture, let's say, or different layers that you can subdivide all your solution. Let's say that, let's start in the right side with a tiny edge that is part of the far edge. So let's say that in the tiny edge, you are going to find sensors, streaming devices, cameras, that kind of things. Just the sensors in general. Let's say that the tiny edge is going to have these IoT devices, let's say. Let's say that IoT is more like you have sensor and you do a specific processing just to capture that data. But what happens if you want to process or transform that information? Maybe you can send the data that your sensor captured to a cluster. So that's the way that the far edge comes. You can find some Kubernetes cluster in this layer and process information locally near to the source of the data. Let's say that, for example, you are in a hospital and the sensors are capturing temperature and oxygen and that kind of things. So you can process that information in a Kubernetes cluster. Maybe, let's say that the final result, you want to show this information in different hospitals or different locations. You want to move that information that was processed locally to the cloud. That's the place that you are going to find the near edge. That is, let's say that a bridge using the LTE networks, the networks that use the smartphones for the 5G networks and that kind of networks that the smartphones uses. So the near edge is going to be like just the bridge to go to the cloud layer. In the cloud layer, let's say that depending how is your solution defined, you are going to find databases, instances, managed services, or maybe you can use local clouds or private clouds using OpenStack, VMware, or something like that, or maybe the public provider as AWS, Google Cloud, Azure, or maybe Cibo, that is especially given K3s and Kubernetes clusters. So in this small diagram, you are going to see how the data moves to the cloud, starting capturing the data in the tiny edge, processing the information locally at the far edge, using the bridge to move to the cloud layer in the near edge, and in the cloud layer is the final result of the information, maybe, depending on your solution. So edge computing has like different use cases. Edge computing, let's say, in general, process information locally near to a source of data. You can use this for the smart farms, smart homes, other systems, federated learning, geolocalization applications or geo-tracking application like Waze, forecast, etc. So it has like a lot of use cases. Even the gaming, let's say that our device, let's say a Nintendo Switch is our local device that processes the information, and when the information is processed, this device moves the information to the cloud. So it's like a sample application how edge computing works. Maybe edge computing exists in the past, but right now we have a name for this kind of situation. Now it's called edge computing. So K3s is a lightweight Kubernetes that is designed for this kind of use cases, IoT and edge computing. Sometimes the people say that IoT is limited just to use sensor, maybe small controllers like Arduino or that kind of things. But when you have to do more intense processing to your data, you need a small computer. When you are using a small computer, you are using the edge computing. Sometimes the people mention that to have some difference between IoT and edge computing. So if you are using a small computer, it's more like edge computing thing. If you are using just small sensors and microcontrollers to process just small parts of information, nothing too complicated, it's more IoT. But in reality, IoT and edge computing complement each other, so are not separated. K3s, this lightweight Kubernetes, remove all the parts of a regular Kubernetes that you are not going to use, just to create a Kubernetes that has enough pieces inside to work as a regular Kubernetes without extra things that you are not going to use never. So K3s has this binary and includes all the things in a small binary of 100 megabytes, more or less, maybe more. You can create a single node cluster or the multi-cluster with that and deploy your applications. The thing that you are winning with K3s, that is a lightweight Kubernetes on edge computing, is that you are going to win a way to deploy your applications, automate process, have some order in your applications, updates, etc. K3s is designed more for edge computing and IoT, so has some modifications, especially to run at the edge, like use MySQL instead of this etcd to store all the object information for a regular Kubernetes. Has some support for load balancer, a local load balancer, or let's say the bare metal load balancer, and different things to work as a regular Kubernetes. But if the default components are not enough for you, you can install another ones and create a more custom solution for you and for your specific needs. Well, K3s is part of the CNCF projects. So when we are talking about edge computing, we are talking about local processing, and maybe the device that we are going to use locally doesn't use like a lot of energy or doesn't have that kind of power to process the things. So the ARM processors are the place for edge computing because they don't consume a lot of energy and has like enough power processing to process the data. So ARM has become like pretty popular for this kind of applications instead of the regular Intel microprocessors because Intel has more power, but has more power, but it uses more energy. So when we are processing the data at the edge, maybe the device is using batteries or the solar panel or something like that. So you want to use a device that doesn't use a lot of energy. So that's the idea, to use ARM at the edge. And that's the way that ARM is pretty popular for that kind of solutions. The Raspberry Pis are the small microcomputer, a microprocessor that has a microprocessor and is designed using ARM microprocessors and has a lot of power for this kind of applications. Well, right now they are a little bit limited right now because of the materials and the problem that we have around the world. But there are another devices like Raspberry Pis, like these Rock Pis, the Pine 64, and different devices that does the same job of ARM. It's important to mention that some of these devices are more to create a prototype and not something to use on production. There are some devices, maybe you can visit on the Azure page for the IoT area. They have some devices that are production ready because the weather situations and bad weather conditions and that kind of things. The Raspberry Pis has different models, let's say that the first generation used the ARM version 7, that is more for 32-bit applications. And let's say that the last version of the Raspberry Pi is the Raspberry Pi 4B, uses this ARM version 8 that supports 64 applications. So I think that, well, definitely is better because you have more support for 64-bit applications for ARM. You can use Raspbian, you can use Ubuntu, Alpine, but each operating system has their own challenge to install the things. So right now I am using Ubuntu because it's like, well, it really works really nice. Has like other things that I think that Raspbian doesn't include. I think that Raspbian is more like a Raspberry Pi oriented. Ubuntu is more like for any ARM device that you have. Alpine is more reduced, more complicated, but maybe you can create something that doesn't use a lot of megabytes of software. So it's pretty interesting too. For your Raspberry Pi cluster, you can use like, well, you need micro SD cards with a good speed for writing information, the Raspberry Pi imager to flash your Raspberry device, maybe a case, or as you see, the case that I am using to put more than one Raspberry Pi, a small switch, and an internet connection, because Kubernetes expects to use a stable internet connection or a stable networking connection. This is how a Raspberry cluster looks. And the different kind of connections that you can use is like simple master, well, single node cluster that is just the master and works as a worker, and a multi-node cluster. It has a master and more than one agent that are like the worker nodes to process the information. So you can divide these devices or the cluster over the edge computing architecture. Mainly, you are going to put this K3s cluster on the far edge, and the edge devices that capture information using sensors at the tiny edge, and you are going to communicate the processing information and send information maybe to the cloud, or maybe in a private cloud locally or near to these devices at the far edge. Because the data is a concern, or is the important thing here, let's talk about the CAP theorem. This theorem, or the CAP theorem, relates about the different attributes that the data has to have, or where a distributed system that stores data, how these states of the data are going to be across this system. So basically, you have to, well, this theorem says that this distributed data is going to have two of the following attributes: consistency, availability, and partition tolerance. So the consistency refers when you are reading information and it returns most of the recent ingredient data, or return an error, it fails. Mainly, you are going to find this situation in the regular SQL databases as MySQL, let's say, that process the information using atomic operations to guarantee that the data is written. If not, the system is going to roll back to a previous state of the data. For the availability, refers that all the reads or information is going to contain data, but maybe not be the most recent data that has the database. That happens sometimes in the social networks like Facebook or something similar, like you are writing in your wall and it's not going to reflect the information immediately. If not, it's going to reflect this information after 1 minute or some seconds. So no, it's not like live information. And sometimes that information is lost. And the partition tolerance is more like, well, a decided feature for distributed system that has a lot of machines inside. So this partition tolerance is going to reduce the downtimes about when you are requesting data to a database. So if a node is down, well, let's say that different nodes contains different parts of the data. So if a node is down, just that part of the information is not going to be accessible. We can summarize this CAP theorem using this diagram that has the consistency, the availability, the partition tolerance. And if we are going to choose two of these attributes, we are going to find between consistency and availability the regular SQL databases: SQL Server, Postgres, MySQL, SQLite, and different RDBMs databases. Neo4j is a graph database that you can use to represent relationships between data, and it's pretty interesting, a pretty nice database that you can use. If you are going to choose consistency and partition tolerance, you are going to find, well, you are going to find that there are some risks of some data to become unavailable. That means, well, in this side of this triangle, you can find the NoSQL databases. For example, MongoDB, Redis, or something based on Bigtable. So that's the place that you are going to find the NoSQL databases. Between availability and partition tolerance, that means that the data will be maybe inconsistent. You are going to find databases like Cassandra, CouchDB, React, and Dynamo, or maybe databases based on Cassandra. So this theorem can help you to decide which database is the right one for you, depending on your needs. And repeating about this part of availability and consistency, the problem is about the network. Because let's say you have a regular MySQL database and the network is failing, the database is going to be down. So that's the problem with this kind of databases. So depending on your own use case, you are going to choose one of these databases. But with this CAP theorem, you can find the attributes that your database is going to have. There are let's say, an extended version of this theorem that includes the concurrency of the system. So you can have some questions about to decide which database is the right for you. For example, if you have to select or support SQL language, maybe if you need not the structured data and freedom in the structure of your data, maybe if you need consistency, availability, or partition tolerance, which of these components are more important to you? How many resources your database is going to use? How fast do you want that your database is going to show the information, write or read your data? And if you are going to use replication or a really easy database, a really easy way to scale your database. For example, Cassandra is easier to scale than MongoDB. Talking about Kubernetes, we need to persist this data. So Kubernetes has different storage cluster, or maybe let's call it a storage driver, to manage this kind of persistent data. Because we are using bare metal Kubernetes, K3s, let's say, have some default storage class, but it's not enough. So here is where Longhorn, that is a storage driver made by Rancher, to process this kind of information and give you this persistence. Some of the challenges that you are going to find about edge will be like communicate your sensors with your edge devices, persistent the data, and support your images using ARM. Because you are not going to compile your program for Intel, you are going to compile your program right now using ARM. And the challenge of an edge computing system is to reduce costs too. For the presentation, for the demonstration, I am going to use this Ubuntu for ARM version 8. I am using a Raspberry Pi 4B with 8 gigabytes and a micro SD card with let's say like the premium SanDisk micro SD card to have a lot of speed of writing or reading information. And when you are using Raspberry Pi, you are going to notice the difference between the reading and writing information for a micro SD card. For your device, you have to install, in this case, Ubuntu, prepare the network. You have to activate the C groups that are used to create containers. You have to activate some flags and configure the host name. Once you have configured your device, you have to install a K3s using this command line, and you can disable the regular load balancer because I am using Metal LB as a bare metal load balancer that is more powerful than the load balancer that comes by default on K3s. So you can install your master node because it's a single node cluster. You can install Longhorn with a single line. It's pretty easy to install. You have to wait to install the information, and then you can access to the YAML file to deploy our application. And the last step of this demonstration is we are going to store data on Redis, and we are going to get the data on Redis using an API. Finally, we are going to walk through across the Longhorn user interface. And let's move to that part. As we know, we have our Raspberry Pis running here. Let's move this part. Okay. So I have, well, here is my Raspberry Pi running. If you can take a look, well, here is the kernel that my Raspberry Pi is using. It's a, well, it's a kernel specific for a Raspberry Pi. This Arch64 means that I am running ARM 64-bit operating system. And let's explore a little bit, well, the namespace that we have on this Raspberry Pi. We have installed a Longhorn. Well, in this Raspberry Pi, I have another demonstration that said Knative and a lot of things. My Metal SB that is in charge of give you an IP address for a load balancer, but this is a local IP address. And here is installed Longhorn. The Longhorn side, let's see how many pods this thing has installed all the drivers and all that things and the different storage classes. Here's the Longhorn and everything. And let's explore. I think that I didn't open this part. Okay, here is the demo. A little bit about the code. Here is the YAML file. Let's explore this a little bit. Let me, well, I am using a persistent volume claim here for the Longhorn that I have installed with 5 gigabytes to store data. I am using a config map to configure the Redis password. Well, the best practice here is more to use a secret instead of a config map, but for the demonstration simplification, I think that it's easier to visualize a config map. So basically, I configure here the password, and I have a deployment of my Redis application, and this specific image is just for ARM version 8, a 64-bit image. So in this side, I configured the configuration of Redis, and I set some limits for the Redis, and I mount the persistent volume claim to don't lose data. I create a service for my Redis application, and finally, I have my deployment. My deployment has a Python application that runs on ARM and use my Redis host that is deploying and the password. Finally, I create a load balancer for my demo application to run the information. And let's explore a little bit this part. Let me increase the size of this. Let's say that here is my application. Here is the Redis and running and my demo application right now. If we see the load balancer assigned to this is a local IP address. I have connected a small switch. Let me show you. The switch is here. It's connected to my laptop here. So I have access to that local network. So we have like, let me show you here. We can access the application. We set like, let me show you. I have a no. Well, I have set the load balancer here. The load balancer with the value of my service that is here is the same IP address, but it's a local address. So I can send information. Let's say that I am going to store GPS information, let's say latitude and longitude. And these are my coordinates, and this is going to store the information there. It's going to return done, and then I am going to get the information. This information is stored on my Redis database right now. And let's explore a little bit the code of this thing. This was like the Kubernetes part. And let's explore the Redis client that I created. It's a regular Docker file using Alpine, nothing special here. Here is a little bit tricky because you have to, well, in this version of Docker that I am using includes the buildx command. And here I set how to compile an image to support ARM64. In some cases, in a specific for Python, you have to change the wheel repositories that download libraries for Python compiled to run on ARM. So in this side, I compile the container for ARM64. Here is the small code that I used here that connects to Redis using a host and a password. I send the information here and store the information on Redis, expire the information after 180 seconds, and returns done. And this other, well, is a basic API that get the information for, let's say, the client ID that I assigned here. And that's the way that this thing works. Let me see again. Where is the, oh, here is it. So basically, this is how it works. And the Redis, it's like, it's not this screen. It's like running here. In this site. Let me run something here. Bash. Okay. Let me see if this thing can work. Okay. So if I execute, I am inside the Redis. Out, okay, out. Remember that the password is your password, okay? So if I execute this, here you can see that here's the database right now. Let's say get A. Well, that was the key that I used the last time. And let me check here if I can. Okay. Let me set another. Okay. And let's see if we can see here. Well, you can see that the key was written, was wrote on Redis right now. So after some seconds, it's going to delete this key automatically. And that's a pretty basic example about how Redis works. Well, how a database is deployed at the edge and how Kubernetes deployed at the edge can use a database and how is the flow, let's say. And you can connect this information with an API or some jobs that moves the information to the cloud, depending on your needs, depending on your system. And that's how basically you can implement a small database and a small application using your data at the edge, like this session says, and the main event is like Kubernetes on the edge. No, Kubernetes, the data on Kubernetes, let's say. And that's how it works. And that's basically the example. And let's return to the slides. some resources that you can check: the K3s site, the Longhorn. Oh, the there's something that I missed. Let me see. Here is like the last part, the Longhorn. I missed the part of the Longhorn. Let me see. It's like, okay, here is it. The Longhorn side, and I think that okay, 50-50. Okay, this is the Longhorn, the UI of Longhorn. Here is the storage that we are using on our application. Here is all the volumes, and well, the persistent volume claim that our Redis deployment is using. And it's a pretty nice UI to manage Longhorn. And well, there are different drivers that you can use, like, well, there are another ones, and that's basically what it does. And finally, well, the slides, you can check the slides in this link. And the repository for the code, you can check the repository of the code on this link. Well, my book, if you want to buy my book, here is a a small link. It's available on Amazon. I have different use cases about the edge, databases, using GPS, and microcontrollers and everything. And you can use this this book also to learn Kubernetes, or learn Kubernetes, and if you want to do something using hardware. So the book is available there. And my contact, my email, if you want to write me, if you want to follow me on Twitter, I post a lot of things, what I am doing, conferences and everything. Maybe I can introduce to somebody on the ecosystem. So
very good.
That's everything.
Simple instructions, buy the book. All right. That's the easiest thing you can do. You have the link. It's getting close to Christmas. Give yourself the gift of giving and buy the book. And on top of that, follow Sergio on Twitter. I shared his link as well there. So everyone's got the link. This is super good. Very hands-on, very practical, very end-user focused, which is what we always want to see here in the community. Now that you've written one book, are you already thinking about your next one?
Well, I think that, let's say, well, the last week or maybe a few days ago, I was talking with somebody about this. I think that right now, when you finish to write a book, I think that you become in a second phase about promoting your book. So I think that more in the second phase right now. Let's say that I am going to create, well, I have to create I want to create a Discord. I have some community around this topic about the chapters, or, well, support the readers, let's say, and somebody that wants to read the book. I have something. We are going to give away like 3 books in this session. Maybe Bart wants to decide how to give that books. You want one of the with a digital book right now. It's not a printed version. So, well, as I was mentioning, I am in the second phase right now, promoting the thing and everything. And I have, like, let's say, like a dream about books. Like, this book is more like a technical thing for edge computing, but I would like to write a book about more theoretic thing, about maybe operating systems with Kubernetes, maybe, or oriented more to containers and cloud native, but the theory behind, not just the technical part, like a book where the universities can use to teach to people, or, well, something more theoretic, like academic book or something like that. But, well, who knows?
No, I mean,
But
it makes sense. And you have worked in university, so you have that mindset and understanding of how to present materials in that format. I think it's a great start with what you've written now. And remember, folks, buy the book. And Sergio, we'll think a little bit about what we can do to give away those copies as a way to give an incentive-based format in order to get that. We did have a comment from one of our most wonderful community members. I think you may have met him before. His name is Jonathan Gonzalez, and he's from Chile. And he asked, have you tried Cloud Native Postgres in your Raspberry Pi cluster?
yeah, it's not to promote my book, but I have some part in the book that I deploy a Postgres database. So yeah, it works on a Raspberry Pi. I think that one of the advantage of Postgres, let's say that in the Kubernetes ecosystem, we use a lot of the Grafana dashboards.
Sure.
So Postgres and MySQL has support for Grafana dashboards. By default, you don't have to pay anything. So I think that is a good advantage using Postgres and MySQL and complement this thing to create your own dashboard on Grafana. So I think that is a good idea, and Postgres runs on a Raspberry Pi. But I think that you need the Raspberry Pi that supports 8 gigabytes, because it's like, for me, I think that you are going to get the better benefit using this device. And the other ones, I think that are okay, but maybe just for applications. You want to deploy something more heavier, maybe the last one that has 8 gigabytes, more or less.
All right, good to know. And thank you, Jonathan, for asking the question. He's very excited. And that's no surprise. Sergio, you know our community quite well. And so, there's a bit of a tradition that we have that while you are giving your presentation, we have our amazing artist who's in the background. Can you see my screen? All right, so this is Angel's artistic depiction of the wonderful talk that Sergio just gave us, showing the different elements and ingredients that were involved in that. ARM is actually, relatively speaking, if we're talking about things in the Kubernetes world or cloud native, or we're just talking about how you said operating systems, ARM is something that I've been hearing about for quite some time. Technology that I work when I was working with DevOps and IT operations team, heard a lot about this technology. So it's nice to see that this is still playing a very relevant role in the ecosystem. And then it's the other things that you mentioned there regarding edge computing, regarding the importance of persistence, the great example of using Longhorn as well. Really, really enjoyed that. So absolutely phenomenal talk. Sergio, we need to maybe do this talk again in Spanish or do another talk in Spanish, because I was talking today to Ramiro Berriesa from Octeto, and I was like, hey, we should do like a bigger event like in Spanish. We can focus it on data on Kubernetes technologies. So I definitely think we need to get that going. I'm thinking February of next year. I want to make sure that we don't have any conflicts with KCDs that would be happening in Spanish, as you're very active with Guatemala. And also there was some of the folks from KCD Spain are interested in creating more content in Espanol, which is fun to do. So like I said, you have the link to Sergio's book. You've got the link to his Twitter. If you have any questions, we'll be sharing the slides and giving you a fast track about how you can get a hold of one of these books. All right. And yeah, very, very good stuff. So yeah, Sergio, anything else before we say goodbye?
I think that I missed something. Or KCD Guatemala is going to be in Spanish, of course.
Very good.
It's going to be at the end of March of the next year.
Very good. So like a month before KubeCon. Yeah, that's cool. That's good. That's good. That's good. So yeah, folks, definitely check it out. There's a wonderful cross-section of people that participated in this year's KCD Guatemala, and a whole cross-section, like I said, students, working professionals, people on the business side, really, really good mixture. And this is what community is all about. And even if you don't speak Spanish, just come and hang out and learn. Everyone's very, very friendly, and plenty of people also speak English. So you can enjoy that. Like I said, one of the cool things about the cloud native community in general is that we have so many different cultures, languages that are being represented, and it's one of the most beautiful things we have to offer. So please take advantage of that. Sergio, thank you very much. Have a wonderful day, and we will talk soon. Okay?
Yeah, of course. Thank you, Bart.
All right. Take care, everybody.